So this presentation is about the fat boot sector. A few comments on the boot sector before we get into the nitty-gritty. So it is the very first important data structure on a fat volume. It's always the first sector on the disk. And the reason that is important is because this way the operating system never has to worry about where to go to get the startup information. It always knows to go to the first sector to get the information with which it uses to access the disk. So being first sector or zero sector is really important. Sometimes this sector is referred to as the boot sector, sometimes the reserve sector, or even sometimes the zeroth sector. Okay? But the most important fact about this is that it's the first sector of the volume. Okay? So I'm breaking this up into 4 different sections. I've broken up the boot sector and its contents into 4 sections so I can more easily explain them all. So the first section is pretty short. The first 3 bytes are a jump to the boot code. This is going to tell the operating system where to jump to actually get the startup code. Okay, and this will be pretty much non-discernible to you unless you're really good at reverse engineering Intel machine language. The OEM name might actually mean something to you. Normally, for the example I'll show you, this is going to be MS-DOS 5.0. Could be a lot of different things. Now, it's important for me to point out that there's a lot of stuff on the internet that is not exactly what I'm telling you right now. That's because there are a lot of versions of FAT, and this goes back to the early 80s. So you could actually go and search the internet for answers and stuff, and you could actually be completely wrong because it's a different version of FAT, an older version of FAT. What I'm going through here is the most modern version of FAT, so that you're sort of in the present time, which almost everything's going to be. I'm not sure you're ever going to get anything that's not. So just be careful. I know I get a lot of questions and comments from people. They say, well, I found this thing on the internet that goes against what you said. And that is most likely true. In fact, I can guarantee you. But I'm using the latest version of FAT. Okay, so the first data structure within the boot sector you get is called the BIOS parameter block. And the BIOS parameter block specifies sort of how the disk is laid out and different things. So bytes per sector, in most cases, as we've already said in this course, it will be 512. But it doesn't have to be. Remember, I also said that this could be something besides 512. That's why it's a variable amount that is stored here. The next value is sectors per cluster, and in most cases this will be 8. So remember, 8 times 512 is 4092. So most clusters are going to be 4092 bytes. Now the next field is deceptively simple. It says reserve sector count. So you might think, oh, well, I don't need to worry about this. I'll just ignore this field. But it is a very important value, because what happens is the reserve fields are going to be your boot sector, and then has some things in here that were added later that help the operating system optimize disk access, and then comes FAT1 and FAT2. So everything from the boot sector through FAT2 is counted in the reserve sector count. That's a very important thing, as we'll see when we look at some source code. FAT count is normally going to be 2. The reason FAT count is 2 is because we have FAT1 and FAT2, and they're both copies of each other. The reason they're copies is because it's such an important data structure. The other values are mostly for the operating system to manage the disk. So I normally don't use those. I actually skip over the rest of the fields. When we run the actual program, I'll show you those. But for now, you can just sort of gloss over those and ignore those. After the BIOS parameter block comes something that came with later versions of FAT called the extended BIOS parameter block. And the first one is logical sectors per FAT, and this is how many sectors each FAT has. I think for the example I'm going to show you, it's 15,568. So that's how many sectors for each FAT. So this would be 15 568. This will be 15,568 sectors. The cluster number of the root directory eventually we'll end up using. Normally that's going to be 2. We always think of the cluster number of the root directory as 2. However, it's not like you're going to get to sector 16 and find the root directory. This is actually a logical cluster number, not a physical cluster number. Now, the rest of this information may or may not be important, especially like the volume ID. This, if you're trying to track down and match up an investigation to a volume ID, that might be important. The volume label is what you see when you do a directory. On the example I'm going to show you, it's no name because I didn't name the volume. And the file system type you're going to see is going to be FAT32. Okay, so that's the extended BIOS parameter block. And the last section is pretty simple to understand. The boot code, that's actually machine code that the jump code goes to. The serial number, here again, that's used to identify the disk. And that might be important if you're trying to sort of correlate your investigation to a piece of hardware. Now, boot sector SIG 0 and boot sector SIG 1, that's always got to be hex 55 and hex AA. And that signifies the end of the sector. I wrote a C++ program to examine a device that is FAT32. So let's go ahead and go through it and take a look at what I've done, and hopefully that will reinforce your understanding of FAT file systems. So here's a data structure called boot sector underscore info, and this gives you kind of a better idea of how it all glues together. I know I explained it in 4 different sections, so it might be kind of hard to understand how it all fits together, but this should help a lot. So that first section that I explained is right here. Okay. The BIOS parameter block comes next, and we're going to take a look at that data structure in just a minute. The extended BIOS parameter block is its own structure, and we're going to take a look at that in a minute. So this was the first section I explained, this was the second section, this was the third section, and this was the fourth section. Notice that I have this should be 55 hex, this should be AA hex, which marks the end of this sector. Now, on the disk, it's not like all sectors are marked with 55AA. Only certain sectors are marked with that. Really, it's only the first few sectors, including the boot sector and the FS. So now let's scroll up and take a look at the BIOS parameter block. Here's the BIOS parameter block. Okay, bytes per sector should be 512. Sectors per cluster should be 8. Reserve sector count will be a number, and that will be the number that you, from the very beginning, boot sector and the FS, that will be where the very first FAT can be found. Reserve sector count is everything before the first FAT. FAT count will be 2, root dir entry count. Now, normally that's going to have maybe more than 1 or 2, but right now, since there's only one root directory cluster, it's going to be 0. Okay, and the rest of this information is mostly for the operating system to know how the hard drive is set up. Okay, so that's the BIOS parameter block. Now the extended BIOS parameter block, logical sectors per FAT, and remember we've already talked about what that meant. That means how many sectors a single FAT is going to be, and there are 2 FATs. Drive description. Most of this is going to be unimportant for your investigation except for cluster number of root directory. In general, that's going to be 2. Volume label, and you'll see it's no name, but it could be anything, whatever you name the device. And file system type, for this it's going to be FAT32. However, it could go back to FAT16 and FAT12, but it's going to be rare that you ever encounter those. Okay, so here I am. Let's just kind of recap. The first information here, BIOS parameter block, extended BIOS parameter block, and then the rest of the code. And this serial number, you might pay special attention to that because it can maybe help you in your investigation, kind of correlate what you're correlate the hardware to your investigation results. Okay, so here's the main boot sector, data structure. Now I do this in order to make sure that I know how many sectors per cluster, how many bytes per sector. I don't really care for this right now about free clusters and total clusters, but I do care about these two pieces of information right here. And normally it's going to be 8 sectors per cluster and 512 bytes per sector, but we don't want to take any chances in case this particular operating system instance isn't those sort of famous and known values. Now the next thing I do is to open the disk, and the Windows API doesn't really consider opening a disk any different than opening a file. So it's a special type of file creation that it uses to open the disk. And in this case, it's the O drive, and my O drive happens to be an 8 gig freshly formatted USB drive. Now when I say freshly formatted, I don't mean a quick format. I mean I went to a low-level format, so it's completely wiped clean. Okay, so we open that, and right here we read the actual data structure. Now I have to be really careful because my capture program and my debugger sometimes conflict. So let's go ahead and see if I can do this without messing either one of them up. So I'm going to start debugging, and it hits here. Go ahead and step over. Now here's my data structure. Let me go ahead and examine that in Visual Studio, which is pretty good about stuff like this. I should be able to move that over. Okay. So there's the boot sector. The jump to boot code, you're probably not going to make much sense of that. If you want to, you can take a look at it. The OEM name, though, is real interesting, MS-DOS 5.0. And here again, you know, a lot of the examples online are not going to be MS-DOS 5.0. And that's your first clue that the information you're going to see is going to be different than what I'm showing you. However, since I'm using the debugger, it's hard to dispute these data structures. Okay, BPB stands for BIOS parameter block. So that's its own data structure, so let's examine that. Bytes per sector, the typical 512. Sectors per cluster, the typical 8. This is an important value. Reserve sector count, 1632. That means from very beginning, 0, boot sector, all the way to the first FAT. Between there and the first FAT is going to be 1632 sectors. And that's how you know where to go to read in the FAT. FAT count is 2, meaning we have 2 copies of the FAT. That's because it's so important. And the rest of this information I'm generally going to ignore because it's mostly for the operating system. However, for your investigation, you will still record all the information. You just may not need it to do the rest of the investigation. So that's the BIOS parameter block. I'll close that off. The extended BIOS parameter block, which was added in later versions of FAT. Okay. Logical sectors per FAT, 15,568. So that means each FAT is going to be a total of 15,568 sectors. Okay, let's see what else is important here. The volume label here is pretty important. It says no name here because I didn't name it, but it could be just about anything as long as it's fits within the space. File system type here it says FAT32, and here again, if it's not FAT32, then it's not going to match what we're talking about. So let me close that data structure up. The boot code is probably not going to mean a whole lot to you. Actually, there is a string with some sort of text for an error text in it, but here it is. So you can actually read that. There is some readable text there, but still probably not going to mean a whole lot to you. Serial number, that value might be important for correlating your investigation with hardware. And finally, the last 2 bytes, hex 55 and hex AA. Okay. So that's the examination of the boot sector and the data structures contained within it.